Standard form, part 3. So we've looked at standard form, graphing linear equations in standard form when your x and y intercepts were integers, when they weren't integers and we had decimals. The one thing that we haven't looked at yet is if I have an equation in standard form and I don't have a separate x and y intercept. How could that happen? How could you have a line? How could you have a line? And I'm not talking about a vertical line or a horizontal line, because we do know how to graph those. But how could we have a line that has some sort of a slope to it and doesn't go through both the x and y axis in different places at some point? Can you imagine that line? Let's take a look. If I put a ruler on it, it's still going to be a straight line. So like if I had a line like this, it goes through both, right? Even if I had a line like this, you guys see that eventually it would go through? So, right. One example would be vertical, but we do know how to graph vertical lines. That would be something like x equals 5. And we do know how to graph horizontal lines. That would be something like y equals 5. But when can I have a line that doesn't cross the axis at two different places? Yeah. What if I have a line that goes right through the middle? If you have a line that goes right through the middle, the trick that we learned for standard form won't work. Okay? For example, if I had something like this, 2x plus y equals 0. And here's why it won't work. If we do the trick that we learned by finding the x and y intercepts in our t-chart, the x-intercept would be 0, the y-intercept would be 0 divided by 1, which is 0. And the x-intercept would be 0 divided by 2, which is still 0. So if I plot these points, it's actually the same point. Can I make a line based on one point? I could, but I don't really know where to make it, right? If I only have one point, the line could be like this, it could be like this, it could be like this even. I don't know where that line goes if I only know one point on the line. So there's a few things you can do. One thing you could do is just pick another point. You could pick a different number for x or y and plug it in and try to find another point on your line and then graph that way. Right? So, well, we could. So, for example, if I picked, well, I want to know when y, well, let's pick something for x. I want to know when x is 1, what would y be? Okay, well, if x is 1, then I would have 2 times 1 plus y equals 0. So 2 times 1 is just 2. How would I solve 2 plus y equals 0?
Which would be 3.
What would I need to do to solve this?
1. No,
I need to get rid of the
2 from.
I need to subtract the 2.
So it's negative y.
So y would be negative 2. So when x is 1, then y is negative 2. I could put that point on my graph. And then all of a sudden, I can connect those 2 points in the form of a line. The trick with this is it can be hard to know which points will come out as perfect integers. Sometimes you might pick a point and then the other one is like this weird decimal, which is okay, it's just not ideal. So I'm going to show you another trick. Instead of picking a value of x other than 0 and finding what y would be, there's something else we can do. Okay? So anytime a line goes through the origin, anytime it goes through the origin, the standard form equation will equal 0. So if you ever see an equation that equals 0, if you see a linear equation in standard form with both x and y equaling, are there two L's in equal? 0, ... This is what we're going to do. So if you ever see a linear equation in standard form, which means x and y together on the same side, and you have both x and y, and it equals 0, what you do is convert it into slope-intercept. And it's actually pretty easy usually to convert it into slope-intercept form. So for example, with this equation, I only have to do one step to convert this into slope-intercept. Slope-intercept form is y equals. So what's in the way of y right here? If I want just y alone on that side, what do I have to get rid of from this side of the equation to get it so it's just y?
2x.
I have to get rid of the 2x. So if I had 2x plus y equals 0, I can convert this into slope-intercept form by just subtracting 2x from both sides. Y now equals 0 minus 2x, which is negative 2x. And this is slope-intercept form. I could think of it as y equals negative 2 over 1x plus 0. Right? These are the same thing. Negative 2x and negative 2 over 1x plus 0. This just looks more like slope-intercept form. Because we see, oh, there's a 0 there. There's nothing there, so that means there's a 0. And then our denominator here is a 1. So look, if I were to plot that, start at 0, go down 2 over 1. Hey, that's exactly what I said we were going to get. So this is just kind of a trick. If you have a standard form that equals 0, you can convert it into slope-intercept form. Let's do another example of this. 0 point will still be on our graph because it can't equal 0. What if I had something like this? 3x plus 6y equals 0. How would I convert that into slope-intercept form? First of all, do I need to?
You have to do. So you
Because it equals 0, so I do.
So you subtract 3x.
So I subtract 3x from both sides.
No, which is 6y equals 3x.
6y equals negative 3x. Oh, that's not quite in slope-intercept form yet. That's not in slope-intercept form yet, though. Why not?
Because there's no x. Y.
What's in the way of the y?
We have to subdivide.
We have to divide off that 6. We'd have to divide both sides by 6 to see that y equals negative 3 over 6x is how I would write that. Or, that's the same thing as negative 1/2 x. So how would I graph that? Think of it as slope-intercept form. Think of it as plus 0 over here. Alright, so I've got my 0. I go down 1 over 2. Down 1 over 2. And I could see that that line would be right there. Again, you're not going to do this for every problem. You're only going to do it for the problems where what?
Where there is a equal 0.
Yeah, where it's standard form equaling 0. Exactly. Do one more example. What if I had something like, actually let's do two more. Negative 2x plus 3y equals 0. How could I convert that into standard form and graph it? What do I need to do to move the negative 2x over? Add 2x. So before I was subtracting x, if I have a negative 2x, I would need to add 2x. So I've got 3y equals 2x. And then what's in the way?
3.
The 3. So I'm going to divide both sides by 3. And I would write it like this. Y equals, just focus on the numbers. 2/3. Oops. That's not a 2. 2/3 x. Y equals 2/3 x.
Plus 0.
Think of it as plus 0. So we know, okay, we're starting here, and then 2/3 up to over 3. And that's our line. Okay, one more example. What if I had something like this? Negative 5x minus 4y equals 0. Let's say I wanted to graph that. Do I need to convert that into slope-intercept form? Why? Because it equals 0. I could try to use my t-chart method. What would happen? What would happen if I used the t-chart method? If x is 0, then we have negative 4y equals 0, so y would be 0. If y is 0, then x is 0. It doesn't work. I only have one point. I only have one intercept. The x and y intercept are the same point, and they are right in that middle. So that's why we're converting this, right? Just don't want you guys to forget why we're doing this, because the trick that we learned doesn't really work. So let's solve this one. How do we convert this?
So you have to add 5.
Add, not 5,
Oh,
5x. Yep, because I want to move this thing off of this side. So then I have negative 4y equals positive 5x. Divide both sides by negative 4. So I then have y equals negative, not 4/5, but 5/4. So this number stays up top. This number goes down bottom. X. And I would think of that as plus 0. Okay? How can I graph this? Yeah, so start at the 0, right? Because of the plus 0. And I'm going to go down 5. 1, 2, 3, 4, 5 over 4. And that's my line. Right? Very good. So that's kind of the new thing that you'll see on the homework today. Now the homework will be a mix of problems. It's going to be all in standard form for now. I'm not going to throw in slope-intercept form. But you will see some problems that look like this. 2x minus 4y equals 4. Some problems that look like this. X equals 5. Y equals 0. And you will see a couple of problems that look like this. 4x plus y equals 0. So let's talk about the strategy that you would use on each of these types of problems. What strategy would you use to graph this problem? Make a t-chart, right? Because I know my x and y intercept are going to be different. What's my y intercept? If x is 0, y would be
1. Negative 1.
4 divided by negative 4, negative 1. If y is 0, x would be 4 divided by 2, which is 2. What strategy would I use to graph these?
You just
We know how to graph these. We know that if we have x equals, then we find where x is 5, and we just make a line that goes through there, right? If we have y equals 0, we find where y is 0, and we make a line where x can change, but y is always 0. So we have to kind of remember, this is a vertical line, and this is a horizontal line to that point. And what would be our strategy for graphing this one?
Or that thing that we.
Yeah, so if you make a t-chart for this, the trick is that you can't make a t-chart with 0 because 0, 0 is 1 point. So then we'd have to pick a different value for x to find y. You could do that. You could say, okay, if x is 1, plug it in, find what y would be. That is one way of solving this. What's the other way that we just went over? If standard form equals 0, we do what? What would we do with this one? Look back at your notes.
Subtract. Get rid of.
Yeah, I would subtract the 4x. Why? What am I doing?
Because you're going to get the y on one side.
I'm going to get the y on one side. That's called slope-intercept form, right? So I would convert it to y equals negative 4x, or I could think of that as y equals negative 4 over 1, x plus 0. It's the same thing, because 4 and 4 over 1 are the same, and nothing and plus 0 are the same. So convert it to slope-intercept form. So just remember, they're not all going to be needed to be converted into slope-intercept form. Some of them you can use the t-chart strategy. Some of them you'll recognize as vertical or horizontal lines. And some of them, the t-chart strategy will not work very well. So we might think about converting them into slope-intercept.
I mean, like it could work, it would just take longer.
Well, yeah, the t-chart strategy can work as long as you pick something else for x. That's a really good point. A t-chart is actually always a way to graph something. If someone gives you an equation that you've never seen before, and you have no idea how to graph it, you can always make a t-chart. You plug in points for x and find what y is. That will always work for making a graph. It's just, if you don't know the pattern that you're looking for, it can be hard to know what points to plug in for x or y, right? So that's why we kind of learn these patterns and these tricks. And as we see different types of equations, we try to recognize those patterns. Oh, I know that this is going to have those two x and y intersects. I know that this is going to be a vertical line, right? I know that this one's going to go through the origin. It's going to go through the middle because it equals 0. And once you start to recognize those patterns, it becomes easier to graph a bunch of different things. Okay.